Good day. Our topic today is specific heat capacity. Our objectives are to 1. Define specific heat capacity, and 2. Solve problems involving the use of specific heat capacity. Specific heat capacity is defined as the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. So we have our formulae. Small c is equal to delta E, the change in energy, divided by m times delta theta, the change in temperature. Or, rearranged, the change in energy is equal to the mass times the specific heat capacity multiplied by the change in temperature. So the m, mass, is measured in kilograms. The small c, specific heat capacity, is measured in joules per kilogram degrees Celsius. The change in energy, E, is measured in joules, and the change in temperature is measured in degrees Celsius. A few specific capacities that you should know about but are not required to memorize are in this table. One of the most commonly used ones that we'll be looking at is the specific capacity of water, which is 4,200 joules per kilogram degrees Celsius. Alcohol has about 2,400, ice about 2,100, sand and granite around 840 and 800 each, glass 670, copper 390, and iron 460. If you look at this table and look at similarities, you'll notice that water and alcohol, which are liquids, have some of the highest heat capacities, and metals like copper and iron have the smallest heat capacities. That explains why when you touch something like a metal, it feels cool to the touch, because when you touch it, it doesn't take a lot of heat energy to heat it up. So the heat energy from your hand quickly transfers to that metal and it cools off your hand. So it tricks your mind into thinking that it is cooler than it is, because it conducts and draws away heat from your hand faster than something with a higher heat capacity, such as wood. Let's look at an example. A pot of negligible mass contains 500 grams of water at 30 degrees Celsius. How much thermal energy is required to bring the pot of water to its boiling point? Assume that the water is pure and is at sea level. So, how do we work out a problem like this? 1, the mass is 500 grams, which we have to convert to kilograms. Dividing by 1,000, you get 0.5 kilograms. The specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. The change in temperature, since the change in temperature is from 30 up to 100, then that will be 70 degrees Celsius. Why does it go up to 100? Well, as you should remember, the boiling point of pure water at sea level is 100 degrees Celsius. So our formula, EH is equal to MC delta theta. Multiplying 0.5 kilograms times 4,200 joules per kilogram Kelvin times 70 degrees Celsius, we get 147,000 joules. So here's a practice problem for you. 25.0 grams of copper was heated from 20 degrees Celsius to 80 degrees Celsius. How much heat energy was used to warm up that copper? Use the specific capacity of copper to be 390 joules per kilogram degrees Celsius. And pause the video at this point. When you have finished working it out, then you proceed to unpause it. I will move to the next slide in 3, 2, 1. Did you get it correct? If you did, good for you. If not, I hope you can spot your mistake and make the corrections. That is all for today.